Today, we will dive into the most astonishing extremes offered by our planetary neighbors, from scorching heat to near absolute cold, colossal storms, and atmospheres that defy comprehension. Mercury, for example, is so close to the Sun that its surface could melt lead during the day and still drop to freezing temperatures at night. One spin and we find ourselves on Venus, where the dense, toxic atmosphere creates the fiercest greenhouse effect known, turning the planet into a lethal oven. Beyond that, Mars shows us how the lack of magnetic protection and a thin atmosphere leave its surface exposed to radiation and dust storms capable of enveloping the entire planet. Each of these planets, with their own challenges, seems straight out of science fiction, yet they are part of our cosmic neighborhood. The giants Jupiter and Saturn demonstrate that size can also be extreme. Storms lasting centuries, pressures that would crush any earthly vessel, and radiation belts that would be deadly in seconds. As if that weren't enough, Uranus and Neptune, in the icy fringes of the solar system, challenge the imaginable with impossible tilts, supersonic winds, and temperatures approaching absolute zero. Even dwarf planets like Pluto, relegated to the periphery, hide astonishing phenomena such as methane snows and atmospheres that appear and disappear. But why is it so important to study these extremes? Beyond fascination, understanding how each planet survives or succumbs to its extreme conditions gives us fundamental clues about the evolution of worlds and the possibility of life beyond Earth. In this journey, through the most extreme planets of the solar system, we will discover what makes each one a unique case and what they can teach us about the delicate balance necessary for life to exist. How far can the limits of nature go? Get ready to find out. Mercury, the planet closest to the Sun, is a world of extremes that challenges the imagination. What happens when a planet is so close to a star as powerful as our Sun? The answer lies in the brutal temperature changes experienced on its surface. During the day, when the Sun is at its highest point, temperatures can exceed 430 degrees Celsius, enough to melt lead. But as soon as the Sun disappears over the horizon, Mercury cools rapidly to less 180 degrees Celsius at night. In other words, one side of the planet can be burning like a frying pan on the fire, while the other freezes like an industrial freezer. How is it possible for such a dramatic contrast to exist? The key lies in its rotation speed and the absence of a significant atmosphere to retain heat. Mercury takes about 88 Earth days to complete one orbit around the Sun, but its solar day lasts around 176 Earth days. This means the Sun appears to move very slowly across its sky, exposing each region of the planet to long stretches of scorching heat, followed by freezing nights. Without a dense atmosphere to act as a thermal blanket, heat escapes almost immediately when darkness falls. This feature makes Mercury the champion of thermal extremes within the solar system. But how does this proximity to the Sun affect its surface? Mercury receives solar radiation nearly 7 times greater than that of Earth. Its closeness to the most powerful energy source in the solar system has shaped a hostile landscape where rocks and regolith have been baked and fractured over billions of years. Unobstructed sunlight strikes the surface with an intensity that no other planet experiences. This constant bombardment not only raises the temperature, but also contributes to erosion and the formation of a scarred crust. Could any form of life survive in such an extreme environment? So far, the answer seems to be no. Conditions on Mercury are so inhospitable that even the most resilient known terrestrial microorganisms, extremophiles, could not withstand such a cycle of heat and cold. Mercury is the perfect example of how proximity to the Sun can turn a planet into a place as fascinating as it is lethal, reminding us that the universe is full of worlds where the rules can be completely different from those of our home.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey.
What happens when a planet practically lacks an atmosphere? In the case of Mercury, the answer is fascinating. Unlike Earth, which is wrapped in a rich and protective atmosphere, Mercury only has an extremely thin exosphere, composed mainly of oxygen, sodium, hydrogen, helium, and trace amounts of potassium. This layer is so thin that it cannot even be considered a true atmosphere. It is more like a cloud of loose particles that constantly escape into space. Why doesn't Mercury retain an atmosphere like other planets? The key lies in its weak gravity and its proximity to the Sun, where the intense solar wind sweeps away any light gas that may accumulate. This absence of atmosphere has dramatic consequences. On Earth, the atmosphere acts as a shield, absorbing dangerous radiation and regulating temperature. On Mercury, there is no such protection. The surface is completely exposed to solar and cosmic radiation, making conditions there lethal for any known form of life. Moreover, the lack of a thick layer of gases means there is nothing to soften the extreme temperatures between day and night. During the day, the surface heats up to temperatures capable of melting lead, while at night, the heat quickly escapes into space, bringing the surface down to temperatures below 170 degrees below zero. Could any living being withstand such hostility? The absence of an atmosphere not only implies thermal extremes, but also absolute vulnerability to meteorite impacts and erosion caused by solar wind. Unlike Earth, where the atmosphere disintegrates most meteoroids before they reach the ground, on Mercury, every space rock that crosses it impacts directly against its surface. If an astronaut were to try to walk there, they would not only be exposed to radiation and extreme temperatures, but also to a constant bombardment of particles from space. But how do scientists study such an inhospitable and unprotected planet? The answer lies in the use of space probes equipped with special shields to withstand the brutal conditions. From space, instruments can analyze the exosphere and capture the elements that make it up, revealing that the gases forming Mercury's thin layer largely come from processes like surface outgassing and micrometeorite bombardment. Thus, Mercury shows us an extreme example of what happens when a planet lacks a significant atmosphere. It becomes a bare, exposed world shaped directly by the wildest forces of the cosmos. In the universe of planets, few display a face so marked by the passage of time and impacts as Mercury. Why does the surface of this small planet resemble a cosmic battlefield? The answer lies in the absence of a significant atmosphere, making Mercury an easy target for meteoroids, comets, and fragments of asteroids crossing the inner solar system. Each impact leaves an indelible mark, and over billions of years, these strikes have sculpted a landscape filled with craters, depressions, and scars that tell the story of a planet constantly exposed to the violence of space. One of the most striking elements of Mercury's surface is the incredible density of craters. Did you know that some of these craters are hundreds of kilometers in diameter? The most famous is the Caloris Basin, a gigantic wound over 1,500 kilometers wide. To put it in perspective, this is nearly half the width of all of Europe. Surrounding this colossus are fractured zones and elevations, a result of the shockwave caused by the impact that formed it. But it's not the only one. All over the planet, craters overlap one another, as if many generations of impacts had gathered in the same place, creating a chaotic and fascinating mosaic. What happens when a planet lacks mechanisms to renew its surface? Unlike Earth, where erosion, volcanism, and tectonic activity can erase or transform the traces of impacts, on Mercury, the scars remain intact for eons. This means that Mercury's surface is like an open geological archive, preserving records of collisions that occurred billions of years ago. Some craters show double rings or chains of small pits, evidence of secondary impacts caused by fragments bouncing after the main collision. Moreover, direct exposure to space has generated other unique features. The so-called hollows are bright, shallow depressions, likely formed by the evaporation of volatile materials due to intense solar heat and radiation. These formations have only been found on Mercury, making them an intriguing enigma for scientists. What secrets do these strange depressions hold? What does their presence tell us about the composition and evolution of the planet? Mercury is, in essence, a silent witness to the early history of the solar system. Its bombarded surface reveals not only the brutality of cosmic impacts, but also the fragility of a world without atmospheric protection. Observing Mercury is like leafing through an ancient book whose pages have survived intact through time, offering valuable clues about the origins and fate of the rocky planets that share our corner of the cosmos. What planet is so hellish that it would melt lead on its surface? Venus is the perfect example of an out-of-control greenhouse, a world where the heat is not only unbearable, but breaks any record known in the solar system. At first glance, Venus may seem like a twin of Earth due to its size and rocky composition, but its atmosphere transforms it into a true planetary oven. The key to this phenomenon lies in the greenhouse effect, but taken to the extreme. On Earth, the greenhouse effect is what keeps us safe from freezing temperatures, trapping some of the sun's heat thanks to gases like carbon dioxide and water vapor. But on Venus, the atmosphere is so dense and rich in carbon dioxide that it acts like an impenetrable blanket. The result? Surface temperatures reaching nearly 500 degrees Celsius, enough to melt metals. If you've ever wondered what it would be like to live inside an industrial ceramic oven, the surface of Venus offers an even more extreme experience. Why did Venus become so hostile? Scientists believe that at some distant point, it may have harbored oceans of water, but the intense heat completely evaporated them. The water vapor, which is also a potent greenhouse gas, added to the carbon dioxide, trapping even more heat and triggering a vicious cycle. Without liquid water to regulate the climate, the planet became a thermal prison from which it could no longer escape. The atmosphere of Venus is so efficient at trapping heat that neither night nor distance from the equator offers relief. It's as if the entire planet is wrapped in a gigantic electric blanket that never turns off. In this world, life as we know it would be impossible. The lesson Venus leaves us is clear. An uncontrolled greenhouse can turn an entire planet into the most inhospitable place in the cosmic neighborhood. Could this ever happen to Earth? The story of Venus invites us to reflect on the delicate balance that keeps our own planet habitable. What would happen if you tried to breathe on the surface of Venus? Instead of oxygen, you would find a lethal mix of gases, where carbon dioxide is the real star, making up more than 95% of the Venusian atmosphere. But that's not all. Floating in the air are dense clouds of sulfuric acid, so corrosive that they would destroy any earthly material in a matter of minutes. The atmosphere of Venus is, in many ways, the definition of a hostile environment, where chemistry works against any known form of life. Why does Venus have such a toxic atmosphere? The secret lies in the absence of water and the uncontrolled greenhouse effect. Without oceans to absorb carbon dioxide, this gas has accumulated over millions of years, trapping heat and breaking down molecules in the upper atmosphere. At high altitudes, solar radiation converts water vapor into hydrogen and oxygen. Hydrogen, being very light, escapes into space, while oxygen reacts with sulfur to form sulfuric acid. Thus, the atmosphere becomes a natural chemical laboratory where acidity reigns. Did you know that droplets of sulfuric acid form clouds that completely envelop the planet? These clouds reflect most of the sunlight, making Venus shine brightly in the Earth's night sky. However, beneath that radiant appearance lies a chemical hell. Rain on Venus never reaches the ground. The extreme heat of the atmosphere causes sulfuric acid to evaporate before it can reach the surface, in a perpetual cycle of condensation and vaporization. It's like an eternal storm that never finishes pouring down. Moreover, the atmosphere of Venus is so dense and heavy that each cubic centimeter is saturated with toxic particles. For a human, simply exposing any conventional equipment or spacesuit would quickly show how materials degrade rapidly. Space missions that have visited Venus have survived only a few hours on its surface before succumbing to corrosion. In summary, Venus represents one of the most acidic and deadly environments in the entire solar system, a reminder of how atmospheric chemistry can transform an entire planet into a true hell. What would happen if you tried to walk on the surface of Venus? The answer is as surprising as it is terrifying. Within seconds, the atmospheric pressure would crush you as if you were nearly 900 meters underwater, a depth greater than that reached by most submarines. The atmosphere of Venus is so dense that the pressure at its surface exceeds 90 times the pressure we feel on Earth at sea level. Why does Venus have such monstrous pressure? It all comes down to its extremely thick atmosphere, composed mainly of carbon dioxide, which acts like a gigantic blanket, trapping heat and compressing the air under its own weight. This pressure is not only an obstacle to any attempt at human exploration, but has also been the main challenge for robotic missions sent to Venus. The Soviet Venera probes, for example, managed to survive only a few minutes before being destroyed by the crushing Venusian environment. To put it in perspective, if you placed a steel tank designed to withstand the pressure of Earth's ocean depths on the surface of Venus, it would likely deform or collapse in no time. Is there any material on Earth capable of withstanding such conditions indefinitely? So far, human technology can barely face this challenge. But how does this pressure influence the planet itself? The enormous atmospheric compression directly affects the geological and chemical processes of Venus. For example, the minerals on the surface behave differently compared to those on Earth. Some rocks may melt or react unexpectedly due to the combination of extreme pressure and temperature. Moreover, the pressure contributes to the formation of dense clouds and atmospheric layers that block almost all sunlight, creating a perpetually opaque and hostile environment. So, could any form of life survive under such a crushing load? Scientists believe that, at least on the surface, it is practically impossible. However, some have suggested that perhaps in the upper layers of the atmosphere, where pressure and temperature are more moderate, there could be microbes capable of withstanding extreme conditions. The crushing pressure of Venus not only represents a physical frontier, but also a scientific mystery about the resilience of matter and life. What if, instead of water, rain were an acid so corrosive that it could dissolve metals? That happens on Venus, one of the most extreme planets in the solar system. In this hellish world, the clouds are primarily composed of sulfuric acid, a substance so aggressive that it would destroy any human spacecraft in a matter of minutes. But how is it possible for a planet to have such a type of rain? The key lies in its dense and toxic atmosphere, where sulfuric acid forms from chemical reactions with sulfur dioxide and water present in the Venusian air. However, the story doesn't end there. These acid droplets never reach the surface as they evaporate from the extreme heat before touching the ground, creating a kind of hellish cycle that only increases Venus's hostility. But if acid rain weren't enough, Venus has another surprise: its hurricane-force winds. Can you imagine a wind that exceeds 300 kilometers per hour, wrapping around the planet like a gigantic whirlwind? That happens constantly in the upper atmosphere of Venus. Venusian winds can complete a full circuit around the planet in just 4 Earth days, despite its rotation being extremely slow. This phenomenon, known as superrotation, remains a mystery to science and demonstrates that, even without oceans or seasons, Venus is anything but a tranquil place. Why are these winds so powerful? The combination of enormous atmospheric density and intense solar heating generates currents so violent that the atmosphere behaves like a conveyor belt of toxic clouds and particles. Meanwhile, the pressure at the surface is so crushing that it would be like being nearly 900 meters underwater on Earth. In this environment, any attempt at robotic exploration faces one of the greatest challenges of space engineering: to withstand not only corrosion, but also the force of these colossal winds. Venus is a reminder of how extreme a planet can be. It It is a place where rain never touches the ground and the wind never stops. A world in which the elements conspire to make any form of life, as we know it, impossible. Could any organism survive such conditions? So far, all indications suggest the answer is no. But Venus continues to challenge our understanding, showing us that, in the solar system, the impossible can become reality. What makes Earth so special amidst a solar system full of extremes? The answer is an astonishing and uncommon balance. Our atmosphere acts as a protective shield, regulating temperature and filtering harmful radiation. Thanks to the precise combination of gases like nitrogen and oxygen, life can breathe and thrive. But what would happen if there were a bit more carbon dioxide, like on Venus? Or if we were missing that gaseous mantle, like on Mercury? The balance would be disrupted, and Earth would be as inhospitable as its planetary neighbors. Liquid water is another of the great secrets of our planet. Unlike any other known world in the solar system, Earth maintains its oceans and rivers in a liquid state, neither evaporated by heat nor frozen in a desert of ice. This feature is no coincidence. The distance from the sun, atmospheric pressure, and average temperature work together like a perfectly tuned orchestra. If any of these variables change slightly, life as we know it would simply be impossible. Moreover, the Earth's magnetic field plays a crucial role. Why is it so important? This field, generated by the liquid iron and nickel core, deflects charged solar particles and protects the surface from cosmic radiation. Without it, the atmosphere would erode and harmful radiation would reach the ground, making our planet much less welcoming. It's as if Earth has an invisible shield, constantly defending us from the onslaught of outer space. The diversity of landscapes and climates is also part of the perfect balance. Mountains, jungles, deserts, and oceans create microclimates and ecological niches for countless forms of life. Have you ever wondered what life would be like if the entire planet were a single desert or an endless ocean? The variety of environments allows evolution to experiment and species capable of enduring everything from polar cold to equatorial heat to emerge. Thus, Earth is not only an oasis in the void, but a living laboratory of adaptations and survival. Can Earth be considered an extreme planet? Although we often think of our world as an oasis of life and stability, the truth is that in its most remote corners, it harbors conditions as hostile as those on any other planet. For example, did you know that temperatures below 89 degrees Fahrenheit have been recorded in Antarctica? There, the cold is so intense that breath can freeze in the air and life only persists thanks to astonishing adaptations. On the other end, Death Valley in California holds some of the highest heat records on Earth, with temperatures exceeding 133 degrees Fahrenheit. It is a place where asphalt can melt, and survival depends on nearly impossible strategies. But terrestrial extremes are not limited to temperature. What happens beneath the waves, in the depths of the ocean? The Mariana Trench, the deepest known area, reaches over 11 kilometers below the surface. There, the pressure is more than 1,000 times greater than what we feel at sea level, crushing any unprepared object in seconds. However, even in that total darkness and under that overwhelming pressure, there are creatures capable of withstanding conditions that would destroy any conventional human technology. How do they manage to survive? Their secret lies in the flexibility of their bodies and metabolic processes that can function almost without oxygen. In deserts, the scarcity of water and extreme temperatures create scenarios where only the most resilient life forms can thrive. The Atacama Desert in Chile is so arid that some areas do not receive rain for decades. In this place, microbial life employs strategies that seem straight out of an alien survival manual. They capture water vapor from fog, store nutrients for years, and withstand radiation that would be lethal to most organisms. Could life on other planets employ similar tactics? Even in places that seem inert, like the poles or active volcanoes, life finds a way. In the hydrothermal vents of the ocean floor, where water temperatures can exceed 700 degrees Fahrenheit and darkness is absolute, organisms called extremophils thrive by feeding on minerals and chemical energy without the need for sunlight. These extreme environments, so far removed from what we consider habitable, show us that Earth is, in fact, a planet of extremes. Could this be a clue about the possible existence of life in the most unsuspected corners of the universe? Mars is known as the red planet, but its warm color is deceiving. If there's one thing that defines Mars, it's the extreme cold. How cold can this world get? During Martian nights, temperatures can drop to minus 140 degrees Celsius in the polar regions, a cold capable of freezing carbon dioxide from the air and forming layers of dry ice. Even at the equator, where sunlight is most direct, the thermometer rarely exceeds 0 degrees Celsius during the day and plummets at night. There is no single place on Earth where such a drastic temperature drop is experienced every 24 hours. Why is Mars so frigid? The answer lies in its distance from the Sun, nearly twice that of our planet, and its extremely thin atmosphere, composed mainly of carbon dioxide. This atmosphere, as thin as a shadow, cannot retain heat. It's like trying to keep warm with a veil in the midst of a snowstorm. Unlike Earth, which acts as a natural greenhouse and maintains relatively stable temperatures, Mars loses its heat almost as quickly as it receives it. What effect does this have on the planet? Liquid water, essential for life as we know it, cannot exist permanently on the Martian surface. It freezes or evaporates within minutes, leaving only traces of ice at the poles and beneath the surface. The seasons on Mars are another key player in the polar cold. The planet has an axial tilt similar to that of Earth, resulting in marked seasons. However, Martian winter is especially brutal in the polar regions. Extensive ice caps of carbon dioxide and water expand, covering thousands of kilometers. During winter, the sun barely peeks over the horizon, plunging the poles into months of darkness and temperatures that would make Earth's winter feel like a mere cool breeze. Can you imagine surviving a Martian polar night? It would be longer than many human lifetimes. At the poles, a single day and night can last nearly a terrestrial year. Despite the paralyzing cold, Mars remains one of the favorite destinations for exploration and science. Why is such an inhospitable place so fascinating? The extreme cold is a challenge, but also a window into the past of the solar system and the possibility of life under extreme conditions. If humanity ever decides to settle there, it will have to face a world where the cold is unforgiving, but where every gram of heat becomes a treasure. Thus, Mars reminds us that in the universe, survival depends on understanding and adapting to extremes. What makes Mars even more inhospitable? Its global dust storms, a phenomenon unmatched anywhere else in the solar system. These storms can cover the entire planet for weeks or even months, enveloping Mars in a reddish haze and reducing sunlight to almost zero on the surface. Can you imagine being in a place where, suddenly, day turns into a dark twilight for entire weeks? That's what happens when one of these gigantic storms unleashes. But how does a storm of such magnitude begin? It all starts with Martian winds, which, although less dense than those on Earth, can easily lift fine dust particles due to Mars's low gravity and thin atmosphere. It only takes a small region to heat up more than usual for the wind to pick up dust, and that dust, in turn, absorbs even more heat, creating a domino effect that can trigger a local storm, which can grow to envelop the entire planet. It's as if on Earth, a sandstorm in the Sahara somehow managed to cover all the continents with a cloud of dust. These storms are not only impressive for their size, but also for their consequences. When dust covers the atmosphere, the temperature on the Martian surface can drop, but the upper layers of the atmosphere heat up. Additionally, by blocking sunlight, these storms can paralyze the solar panels of the robots and probes exploring Mars, as happened to the famous rover Opportunity, which ceased to function after one of the most intense global storms ever recorded. Could a human survive a Martian dust storm? Although they do not have the destructive force of a terrestrial hurricane, the lack of visibility, the drop in temperature, and the electrostatic charge of the dust would make any attempt at exploration during a storm extremely dangerous. It is even believed that the electricity generated by the moving dust could affect electronic systems and pose an extra risk for future crewed missions. On Mars, even dust can become a lethal enemy, reminding us that the red planet is, in every sense, a world of extremes. What would happen if we walked on the surface of Mars without any protection? Unlike Earth, Mars lacks a global magnetic field, and its atmosphere is extremely thin. This means that, instead of being protected from cosmic and solar radiation, as we are on our planet, on Mars, we would be completely exposed to a constant bombardment of energetic particles. But how dangerous is this radiation? Experts estimate that, in just one Martian year, an astronaut would receive a radiation dose similar to what a nuclear worker might accumulate over their entire career on Earth. Why is Mars so vulnerable to radiation? The answer lies in its geological history. In the past, Mars may have had a magnetic field, but it lost it billions of years ago when its core stopped moving enough to generate one. Without that invisible barrier, solar wind stripped away much of its atmosphere, leaving the planet exposed. Today, the Martian atmosphere has less than 1% of the density of Earth's atmosphere. It's like trying to protect yourself from the sun with a sheet of paper instead of a sunshade. Energetic particles pass through the Martian atmosphere, almost unimpeded, reaching the surface. What types of radiation would we face there? Mainly two types: galactic cosmic radiation, originating from outside the solar system, and solar radiation, composed of particles emitted during solar storms. Both can damage human cells, cause genetic mutations, and increase the risk of cancer. Even the robots and probes exploring Mars must be designed to withstand these onslaughts, as radiation also affects electronic components. If a human were to remain on the Martian surface for too long without shelter, the effects would be devastating. Does this mean that colonization of Mars is impossible? Not necessarily, but it forces us to rethink how to protect future explorers. Habitats would need to be buried underground or covered with thick layers of materials that block radiation, such as Martian regolith. Even a short walk on the surface would require spacesuits capable of filtering these deadly particles. Radiation is undoubtedly one of the greatest challenges for life on Mars. It shows us how special our planet is and the invisible barriers that protect us every day. The question then is, will we be able to create on Mars an artificial protection as effective as the one we enjoy here on Earth? Jupiter is, without a doubt, the colossus of our solar system. What does it mean to be the largest planet? To begin with, its mass is more than 2.5 times that of all the other planets combined. If Earth were a marble, Jupiter would be a gigantic beach ball. But its size is not the only impressive thing. Its turbulent and ever-changing atmosphere makes it one of the most extreme worlds imaginable. Have you ever wondered what it would be like to live on a planet without a solid surface? Jupiter is, in essence, a huge sphere of gas and liquid, primarily composed of hydrogen and helium. There is no solid ground to stand on. The deeper you descend into its atmosphere, the greater the pressure becomes, reaching areas where hydrogen behaves like a metallic liquid. It's as if you were trying to dive into an invisible ocean, where every meter becomes more and more hostile. One of the most fascinating aspects of Jupiter is its gigantic storms. Imagine hurricanes that could swallow the entire Earth effortlessly. The planet is covered in bands of clouds that move at incredible speeds in opposite directions, creating constant turbulence. These bands are separated by powerful winds and whirlpools, some so large that they could engulf entire planets. Why do these storms form? The answer lies in Jupiter's rapid rotation, which completes a turn in less than 10 hours, and in the internal heat it emits, almost as much as it receives from the Sun. Radiation is also an unrelenting enemy on Jupiter. Its gigantic magnetic fields trap charged particles that bombard everything around them. If a spacecraft tried to get too close without proper protection, the electronics would be fried in minutes. What does this gas giant reveal to us about the formation of planetary systems? It shows us that extremes are not the exception in the universe, but the rule. Jupiter, with its size, composition, and climatic ferocity, is a natural laboratory for understanding the physics of giant planets and the limits of what we know as a habitable world. What phenomenon can last for centuries and be larger than an entire planet? In the heart of Jupiter, the answer rises majestically: the Great Red Spot. This colossal storm is the most famous and ancient hurricane in the solar system, a vortex of clouds that has been spinning relentlessly for at least 350 years, although some scientists believe it could be even older. Can you imagine a storm on Earth that hasn't stopped since before the invention of the telescope? On Jupiter, this is an everyday reality. The Great Red Spot is so gigantic that at its peak size, it could swallow the entire Earth more than twice. Currently, although its diameter has decreased, it is still large enough to devour our planet effortlessly. What causes this immense storm? Its energy comes from the inner layers of Jupiter and the frantic atmosphere that circulates around it. The spot rotates counterclockwise, with winds exceeding 430 kilometers per hour. To put it into perspective, a terrestrial hurricane is a light breeze compared to this Jovian monster. But why is the Great Red Spot red? The answer remains a mystery. Some scientists suggest that the chemical compounds present in Jupiter's atmosphere, when reacting with the sun's ultraviolet light, generate that characteristic reddish hue. Others point to the presence of sulfur or phosphorus. What's fascinating is that, despite scientific advancements, the exact composition and the mechanism behind its color remain unresolved, making it one of the great planetary enigmas. Could the Great Red Spot ever disappear? Astronomers have observed that in recent decades, the spot has been slowly shrinking. No one knows for sure if it will dissipate or if, like a cosmic titan, it will continue to dominate Jupiter's atmosphere for centuries more. What is certain is that observing the Great Red Spot is peering into the fury and beauty of a planet where the forces of nature reach extremes that are hard to imagine. When it comes to planetary extremes, Jupiter is the absolute king in terms of pressure and gravity. But how intense can these forces be on the gas giant? To start, the gravity on the surface of Jupiter, if we could define a solid surface, is about 2.5 times stronger than that of Earth. That means if you weigh 70 kilos here, you would feel the weight of over 170 kilos there. It's a force that would crush any human being before they could even take a step. But the real brutality begins when descending into its atmosphere. What would happen if a spacecraft tried to dive into the depths of Jupiter? The pressure increases rapidly, much faster than in the deepest ocean on Earth. Just a few hundred kilometers below the upper clouds, the pressure already exceeds that of any point on the blue planet. To put it in perspective, at the bottom of the Mariana Trench, the pressure is about 1,000 atmospheres. On Jupiter, that pressure is reached at a tiny fraction of its radius, and it continues to rise to unimaginable levels. Is it possible to find any material that can withstand such pressure? The answer is no, at least with current technology. The spacecraft sent to Jupiter, like the famous Galileo, have only managed to penetrate its outer layers before being destroyed by the combination of pressure and temperature. If we continued descending, there would come a point where hydrogen, normally a gas, turns into a metallic liquid, an exotic state that does not naturally exist on Earth. At these depths, the pressure is millions of times greater than that of Earth's atmosphere. Why is it so important to understand these extreme conditions? Because at the heart of Jupiter could lie clues about the formation of giant planets and the evolution of the solar system. Additionally, its immense gravity affects all nearby celestial bodies, acting as a shield that deflects comets and asteroids. Jupiter is not only the colossus of pressure and gravity, but also a fundamental player in the history of our cosmic neighborhood. Jupiter is not only the largest planet in the solar system, but it is also the most dangerous in terms of radiation. What makes its environment so lethal? The answer lies in its powerful radiation belts, which surround the planet like an invisible shield, but in reality, they are a deadly trap for any spacecraft or living being that gets too close. These belts, conceptually similar to Earth's Van Allen belts, but much more intense, are made up of charged particles trapped by Jupiter's enormous magnetic field. How dangerous is this radiation? If a human could be near Jupiter without protection, they would receive a lethal dose of radiation in just a few hours, many times over. For reference, an astronaut on the International Space Station receives in 1 year what would be absorbed near Jupiter in just a few minutes. Even space probes, designed to withstand extreme conditions, must have special shielding to survive this hostile environment. For example, the Juno probe was equipped with a kind of titanium safe to protect its electronics, and even so, its systems are progressively affected by the constant bombardment of energetic particles. But where does all this radiation come from? Jupiter's magnetic field, the strongest in the solar system, acts like a gigantic particle accelerator. It traps electrons and protons from both the solar wind and the volcanoes of its moon Io, making them spin around the planet at incredibly high speeds. These particles, when colliding with any object, release an amount of energy capable of destroying electronic components and damaging the DNA of any living being. That's why getting too close to Jupiter is like approaching a planetary version of an unprotected nuclear reactor. Jupiter's radiation not only complicates robotic exploration, but it also raises fascinating questions about the possibility of life on its moons. While Jupiter's surface is absolutely uninhabitable, some of its satellites, like Europa, are protected by thick layers of ice. Could these layers be enough to shield life from lethal radiation? Jupiter's case is a clear warning. It is not enough to be far from or close to the Sun. The magnetic environment and radiation belts can turn any world into a tremendously hostile place. Saturn is known as the Lord of the Rings, but what makes this planet one of the most fascinating and extreme in the solar system? Nothing more and nothing less than its ring system, a unique and dazzling spectacle. Saturn's rings are primarily composed of ice and rock particles that vary in size, from tiny dust grains to blocks that could fit in a house. Why does Saturn have such impressive rings, while other planets do not? The answer lies in the combination of its gravity, the distance of materials to its surface, and the absence of large moons in key areas, which prevents these debris from grouping together to form a satellite. How many rings does Saturn really have? Although we often imagine a couple of large rings, in reality, the system is much more complex. It has thousands of smaller rings, so thin that, when viewed from the side, they practically disappear. If you could compress all the rings into a single mass, they would barely exceed the size of a medium moon, but spread out, they cover an area that extends for hundreds of thousands of kilometers. This contrast between the tiny thickness and the colossal extent is one of Saturn's great mysteries. But where do these rings come from? The most accepted theory suggests that they are remnants of moons or comets that came too close to the planet and were torn apart by tidal forces, that is, by Saturn's powerful gravitational pull that literally disintegrated them. It's as if Saturn were a jealous titan, unable to allow a large object to survive too close to its domain. However, the rings are not eternal. Scientists estimate that in a few million years, they could disappear completely, absorbed by the planet itself or dispersed into space. Furthermore, Saturn's rings offer us a window into the past of the solar system. They hide secrets about the formation of planets, the behavior of gravity, and the effects of cosmic impacts. Ask yourself, if Saturn's rings are so spectacular, what other wonders might this gas giant conceal? The beauty and mystery of its rings have inspired generations of astronomers and continue to challenge our understanding of the universe. What phenomenon can challenge our understanding of planetary meteorology? At Saturn's North Pole, there exists a storm with such an unusual shape that it has puzzled scientists since its discovery. A massive perfect hexagon, so large that more than 2 Earths could fit side by side within it. This hexagon is not just an optical illusion or a fleeting figure. It is a gigantic atmospheric jet stream that has maintained its regular shape for decades, resisting the violent winds and chaotic dynamics of Saturn's atmosphere. What accounts for this precise geometry in an environment where everything seems turbulent and chaotic? The explanation lies in fluid physics. When the gases that make up Saturn's atmosphere flow at different speeds around the pole, waves are generated, and under certain conditions, these waves can stabilize into geometric patterns. On Saturn, the combination of speed, temperature, and atmospheric composition gives rise to this hexagonal vortex. There is no other phenomenon like it in the entire solar system. It is as if nature has drawn an impossible figure on a gas giant with a ruler and compass. Within this hexagon, conditions are extreme. Winds can exceed 300 kilometers per hour, and clouds swirl in an endless dance. At the center, a massive storm acts like a hurricane's eye. But unlike terrestrial hurricanes, here the energy comes from the depths of Saturn itself, not from the Sun. How is it possible that this pattern has remained stable for so long? So far, no Earth climate model is capable of perfectly replicating the structure and longevity of Saturn's hexagonal storm. This phenomenon raises fascinating questions. Could there be a universal rule that explains the formation of geometric patterns in planetary atmospheres? Or is Saturn's hexagon a cosmic rarity, a whim of natural forces under conditions that only occur in this gas giant? What is certain is that the hexagonal storm represents one of the most striking and extreme mysteries of our solar system, reminding us that even among the most studied planets, there are still secrets waiting to be deciphered. Did you know that if there were a bathtub large enough, Saturn would float in it? This statement, although it sounds like science fiction, is a direct consequence of one of the most surprising characteristics of the planet. Saturn has an average density lower than that of water. But how is it possible that a planet of such size and majesty is less dense than the liquid we swim in? The key lies in its composition. Saturn is not a rocky planet like Earth, but a gas giant primarily made up of hydrogen and helium, the lightest elements in the universe. Despite its imposing volume, which far exceeds that of our planet, Saturn's mass is distributed in a very loosely packed structure. Its core is relatively small compared to its immense gaseous envelope, which extends for hundreds of thousands of kilometers. In comparison, while on Earth each cubic centimeter of rock weighs much more, on Saturn, that same space would be occupied by extremely light gases. Now, what does it actually mean for Saturn to have a density lower than water? Density is a measure of how much mass is in a given volume. Water has a density of about 1 gram per cubic centimeter, while Saturn's density is just around 700 grams per liter. Thus, if we could cut a piece of Saturn and weigh it, we would be surprised to see that it is lighter than the same volume of water. This property makes Saturn a unique case among the major planets of the solar system. But this fact is not only curious, it also reveals a lot about the formation and evolution of giant planets. Why doesn't Saturn collapse under its own weight? The answer lies in the balance between the gravity that compresses it and the pressure of the gases that expand it, a delicate balance that maintains its shape and size. Furthermore, its low density challenges our intuition about what a planet can be. Not all worlds are solid and heavy. Some, like Saturn, are ethereal colossi that float in the cosmos like giant balloons. This reality invites us to rethink what it truly means to be a planet in our solar system. How much wind do you think a planet can withstand? Saturn defies all expectations. In this gas giant, winds reach speeds exceeding 1,800 kilometers per hour. To put it in perspective, that's more than double the speed of the most powerful hurricanes recorded on Earth. If a commercial airplane flew in this atmosphere, it would be swept away like a leaf in the midst of an unstoppable gale. What causes such atmospheric fury on Saturn? The key lies in the composition and structure of its atmosphere. Saturn is primarily made up of hydrogen and helium, lightweight gases that can move with great ease. The energy comes from both the sun and the planet's own interior, where residual heat from its formation is released. This combination generates temperature and pressure differences that fuel jet streams, similar to the rivers of wind that exist in Earth's atmosphere, but much more intense. The cloud bands we see on Saturn are not just decorative. They mark the boundary between these supersonic winds that swirl in opposite directions, creating a constantly agitated atmosphere. Could any object or spacecraft survive amidst these winds? The answer is a resounding no, not for long. The atmospheric pressure and wind speed would tear apart any conventional structure. Even the most resilient probes sent so far have barely grazed the upper layer before being destroyed by the intensity of the environment. The winds of Saturn are not only the fastest on the planet, but they rival the most extreme in the entire solar system. Why is it so difficult for anything to endure there? Because the airspeed is so brutal that it literally shreds molecules and fragments everything in its path. But how do we know all this if we have never landed on Saturn? The answer lies in space missions and detailed observation from a distance. Probes have measured the movement of clouds and changes in the atmosphere with instruments capable of detecting even the slightest shifts. Thanks to this data, scientists have been able to accurately calculate wind speeds and discover that, on Saturn, the atmosphere is a true machine of uncontrollable energy. Thus, Saturn crowns itself as the king of supersonic winds, a world where the weather is so extreme that it challenges everything we know about planetary meteorology. These winds not only represent a challenge for exploration, but also hold the secrets of giant planet dynamics. Every gust, every air current, speaks to us of a planet that, although seemingly calm from afar, is actually a stage for colossal forces. What other surprises might a world where the wind never rests hold? Saturn continues to challenge our imagination and our technology, reminding us that even in our own cosmic neighborhood, there are extremes that we have only just begun to understand. Uranus is undoubtedly one of the most unique planets in the entire solar system, but what makes it so special? The answer lies in its tilt. Its axis of rotation is tilted almost 90 degrees relative to the plane of its orbit. In other words, Uranus seems to roll like a ball along its path around the Sun, rather than spinning like a top, as most planets do. What accounts for this unusual phenomenon? The most accepted theory is that billions of years ago, Uranus was struck by a massive object, perhaps the size of Earth, which literally knocked it over on its side. This catastrophic collision forever marked Uranus's fate and gave it its characteristic extreme tilt. Can you imagine living on a planet where day and night last for decades? On Uranus, this is a reality. Due to its tilt, for almost half of its year, which equals 84 Earth years, one of the poles can be continuously exposed to the sun, while the other remains shrouded in perpetual night. Thus, each hemisphere experiences long periods of sunlight followed by absolute darkness. This extreme dynamic creates seasons that are nothing like those on Earth. While a season here lasts a few months, on Uranus, a season can extend for over 20 years. What would life be like if your summer lasted an entire generation? The tilt of Uranus also profoundly affects its atmosphere and climate. Scientists are still investigating how this peculiar orientation influences cloud formation, storms, and winds on the planet. At times, Uranus's atmosphere seems strangely calm, with few visible storms, but at other times, large cloud systems appear unexpectedly. Could it be that the energy from such long seasons accumulates and is released suddenly? This erratic behavior makes Uranus a natural laboratory for understanding how extreme climates function under extraordinary conditions. But the mysteries don't end there. Why is Uranus the only planet that exhibits this degree of tilt? Could something similar have happened elsewhere in the universe? The tilt of Uranus not only challenges our idea of how planets should behave, but it also reminds us of how unpredictable the evolution of a planetary system can be. In the quest to understand these enigmas, Uranus becomes a key piece in deciphering the deepest secrets of the cosmos. Uranus is undoubtedly the planet where cold reaches almost unimaginable levels. How cold can a planet get? To answer, it suffices to say that Uranus holds the record for the lowest atmospheric temperature recorded in the entire solar system, around -224 degrees Celsius. This figure is so close to absolute zero that in comparison, a freezing night in Antarctica would seem tropical. Why is Uranus so extreme in this regard? The answer lies in its distance from the Sun, but also in its peculiar composition and internal dynamics. Unlike other gas giants like Jupiter and Saturn, Uranus emits very little internal energy. While these planets radiate more heat into space than they receive, Uranus seems to retain its cold. How is this possible? Scientists are still debating the causes, but one hypothesis suggests that an ancient colossal impact, capable of tilting the planet on its side, may have also expelled or redistributed its internal heat, leaving it without the energy source that keeps other giants warm. Thus, Uranus has become a silent colossus, wrapped in a frigid cloak that defies any attempt at earthly comparison. And what happens beneath this bluish-green atmosphere? In the upper layers, gases like hydrogen and helium, mixed with methane, remain in an almost static state due to the extreme cold. Methane, besides giving the planet its characteristic color, absorbs the solar heat that reaches it and retains it, preventing it from penetrating deeper. It's as if Uranus were wrapped in a thick blanket that, instead of keeping heat in, isolates it even more from the already distant Sun. If there were ever a possibility of walking on the clouds of Uranus, each exhalation would freeze in the air, solidifying before even drifting a few steps away. The cold of Uranus is not just a curious fact, but it raises fascinating questions about the formation and evolution of planets. How does this extreme cold affect the chemistry of its atmosphere and possible internal processes? Could there be some unknown phenomenon under such conditions? What we do know is that, in the solar system, Uranus represents the true limit of cold, a world where energy practically comes to a halt and where life, as we know it, would be impossible. However, it is precisely in these extremes where the universe keeps some of its most intriguing secrets. What would happen if you tried to breathe on Uranus? The answer is simple: you wouldn't survive a second. The atmosphere of this planet is a true death trap for any form of terrestrial life. It is mostly composed of hydrogen and helium, but that's not the most dangerous part. The real hidden enemy is methane. This gas, although used as fuel on Earth, becomes the key ingredient that gives the planet its bluish-green hue and, at the same time, makes its air absolutely toxic. Breathing in a gulp of this atmosphere would be like inhaling a poisonous mix that your body couldn't process. Can anything be more hostile than the poisonous air of Uranus? Yes, if we consider the presence of even more dangerous compounds. Studies suggest that deep within its atmosphere, clouds of ammonia and even hydrogen sulfide could form, the same compound responsible for the smell of rotten eggs. Now imagine trying to survive in an environment saturated with suffocating and corrosive gases, where every breath would be lethal and prolonged contact with these elements could damage even the most advanced spacesuit materials. But why does Uranus have such a different atmosphere from Earth? The key lies in its origin and its position in the solar system. Being much farther from the Sun, temperatures are so low that water and other volatile compounds cannot remain in liquid or gaseous form, which means the planet is shrouded in a mix of light and toxic gases that could never support life as we know it. It's as if Uranus were a giant chemical factory, where extreme conditions prevent any possibility of a habitable environment. Is there any organism on Earth capable of surviving in such an environment? So far, even terrestrial extremophiles, those beings that withstand the impossible, would not endure the poisonous atmosphere of Uranus. The combination of toxic gases, the absence of oxygen, and the frigid temperatures make this planet one of the most inhospitable places in the solar system. If you've ever dreamed of visiting Uranus, you better think twice. Its atmosphere is an insurmountable barrier to life as we know it. What would a human feel if, suddenly, the day lasted for decades and the night seemed endless? This is the reality on Uranus. the planet of extremes in terms of light and darkness. Unlike any other planet in the solar system, Uranus is tilted on its axis so much that it practically rolls along its orbit, with an inclination close to 90 degrees. This phenomenon causes its poles to point almost directly at the Sun for long periods, while the rest of the planet remains shrouded in twilight that can last up to 42 Earth years. Can you imagine living almost an entire human life without seeing dawn or dusk? Uranus's extreme tilt is not just a rarity. It radically transforms its climate and seasons. For nearly half of its year, one hemisphere is constantly bathed in sunlight, while the other remains in perpetual night. This situation reverses after each half-orbital cycle, that is, every 42 years. Why does this happen? Scientists believe that at some distant point, a massive impact with a large body may have literally tipped the planet over, giving it this strange tilt. But how does this prolonged darkness affect the atmosphere and climate of Uranus? Contrary to what we might expect, the temperature between the illuminated hemispheres and those shrouded in shadow does not vary as much as on other planets. This is because Uranus's internal heat is surprisingly low. Ironically, Uranus emits less heat than it receives from the Sun, an anomaly compared to the other gas giants. So, even though sunlight is scarce for decades in certain regions, the extreme cold is almost uniform across the planet, remaining close to 224 degrees below zero, a record low temperature in the solar system. What would be the consequences of such extensive darkness for hypothetical life on Uranus? If any type of organism ever existed, it would have had to adapt to periods of light and shadow longer than any Earth cycle. Plants, if they could exist, would need completely unknown strategies to us, surviving entire generations without direct solar energy. Uranus's cycle of perpetual darkness is a reminder of how varied and challenging planetary environments can be, and how special our own cycle of day and night on Earth is. Uranus, with its eternal seasons and impossible tilt, shows us that in the universe, normality is just a matter of perspective. What makes Neptune so special among the planets of the solar system? This blue giant, located at the edges of our cosmic neighborhood, hides some of the most fascinating and extreme secrets. Although it is over 4 billion kilometers from the Sun, Neptune is not a silent or peaceful place. In fact, it is one of the most active and violent worlds that exist, with features that challenge our imagination and defy science. Neptune is a gas giant, but its intense blue color is not only due to its distance or extreme cold, but to the presence of methane in its atmosphere. Why does methane paint this planet blue? Methane absorbs red light from the Sun and reflects blue, giving us that unmistakable and mysterious hue. Unlike other gas giants, Neptune seems to shine with a deep, almost hypnotic blue, evoking the image of an infinite sea in the darkness of space. Despite its beauty, Neptune is a world of extremes. This planet experiences winds that reach speeds greater than anywhere else in the solar system. How is it possible that, so far from the Sun, there can be such intense storms? The answer remains a mystery, but Neptune's winds exceed 2,000 kilometers per hour, which is more than double the maximum speed of a commercial airplane. Imagining a storm like that on Earth is impossible. It would sweep across continents in a matter of minutes. Moreover, Neptune hides within it a rocky core surrounded by ice and gases, subjected to pressures and temperatures so extreme that scientists believe diamond rains could form. Can it really rain diamonds on another planet? Under the pressure and temperature conditions of Neptune, methane could decompose and release carbon, which crystallizes into diamonds and falls toward the core like an exotic precious storm. Thus, Neptune not only defies the logic of our world, but also reminds us how diverse and surprising the universe can be. When we think of powerful winds, we might imagine the most destructive hurricanes on Earth, capable of leveling entire cities. But what if I told you that those winds are nothing compared to what happens on Neptune? This blue giant has the fastest winds in the entire solar system, far surpassing any storm on Earth. How fast can these winds get? Surprisingly, currents have been recorded traveling at over 2,000 kilometers per hour. That's more than double the speed of a bullet fired from a rifle. What phenomenon can drive such force on a planet so distant and cold? The key lies in the composition and dynamics of Neptune's atmosphere. Although the planet receives very little energy from the Sun, its atmosphere is primarily made up of hydrogen, helium, and a small amount of methane, which gives it its characteristic blue color. However, the real mystery is how Neptune can generate so much internal energy. Scientists believe that the residual heat from the planet's formation, along with unknown internal movements, fuels these extreme winds. In other words, it's as if Neptune has a hidden engine that keeps its atmosphere in constant turmoil, without relying much on sunlight. Can you imagine being on the surface of Neptune? While there is no solid surface to stand on, any spacecraft attempting to descend would be battered by these violent currents. Neptune's winds can change direction rapidly and form gigantic dark storms, making the planet unpredictable and dangerous. Unlike Earth, where friction with the surface limits wind speed, on Neptune, the atmosphere can spin almost freely, allowing speeds to soar to astonishing levels. This phenomenon raises a fascinating question. Why does Neptune, being a planet so far from the Sun, possess the fastest winds in the entire solar system? The answer is still not definitive. It is suspected that the lack of friction, the atmospheric composition, and an internal heat source are key factors. But ultimately, Neptune remains a dynamic mystery, a natural laboratory where the laws of physics manifest at their fullest, challenging everything we know about planetary weather. How cold can it get in our solar system? If we think of the coldest places on Earth, like Antarctica, where temperatures can drop to 89 degrees below zero, Neptune takes that limit much further. On Neptune, the cold reaches levels that defy imagination. Its outer atmosphere can register temperatures of up to 218 degrees below zero. Why is this planet so frigid? The answer lies in its remote location, over 4 billion kilometers from the Sun. There, sunlight is almost a whisper, and the energy it receives is incredibly scarce. But here, an intriguing paradox arises. If Neptune is so far from the Sun, how is it possible that it is even colder than Uranus, which is even closer to the Sun? The key lies in the mystery of the internal heat of the planets. Uranus, for reasons not yet fully understood, emits almost no heat from its interior, while Neptune does, albeit in small amounts. Still, this heat is not enough to counteract the intense cold of space. In its atmosphere, gases like hydrogen, helium, and methane are so cold that methane absorbs red light, giving the planet its characteristic blue color. Have you ever wondered what would happen if you tried to touch the air of Neptune? The atmosphere there is so frigid that any water vapor would freeze instantly. In fact, if we could transport a glass of water from Earth to the high atmosphere of Neptune, it would turn to ice almost immediately. And not only that, in the depths of the planet, the pressure and cold are so extreme that some scientists believe it could rain diamonds, formed from frozen and compressed methane. The cold of Neptune is not just a curiosity. It is one of the reasons why life, as we know it, would be practically impossible on this planet. The chemical processes essential for life are frozen, and the available energy is minimal. However, studying Neptune and its extreme climate helps us understand the limits of habitability and imagine what existence would be like on worlds truly alien to our home. Neptune, in its icy isolation, continues to challenge our understanding of what it means to be at the coldest edge of the solar system. What happens when we talk about storms on Neptune? If you thought that the fiercest tempests only occur on Earth or Jupiter, get ready to learn about one of the most enigmatic and extreme phenomena in the solar system: Neptune's dark storms. These gigantic spots not only challenge our understanding of planetary meteorology, but also show us how dynamic and violent the weather can be at the edges of the solar system. How is it possible that, on such a distant and cold planet, storms develop that rival in intensity with the greatest ones on any other world. Neptune is known for its colossal winds, but its dark storms represent something even more mysterious. They are enormous, low-pressure systems, comparable in size to the entire Earth, that appear as dark spots in the blue atmosphere. Unlike Jupiter's Great Red Spot, which is stable and long-lasting, Neptune's dark storms are ephemeral. They are born, grow, and disappear over the course of a few years. This transient nature raises a fascinating question. What forces trigger and extinguish these storms so quickly? The explanation lies in Neptune's atmosphere, composed mainly of hydrogen, helium, and methane. In this environment, temperature and pressure differences generate updrafts and downdrafts that fuel these gigantic storms. The dark spots, first observed by the Voyager 2 probe in 1989, show bright edges caused by frozen methane clouds rising to great altitudes. With winds exceeding 2,000 kilometers per hour, these storms darken the atmosphere and pull material inward toward the planet, as if they were gigantic whirlpools in an ocean of gas and ice. Why are these storms dark? The answer is not yet definitive, but it is suspected that at the center of these systems, the atmosphere is more transparent, allowing us to see deeper, less illuminated internal layers. It's like looking through an open window in the midst of a dense bluish fog. Sometimes these dark spots are accompanied by bright white clouds made of methane crystals, which further highlight the contrast. The result is a unique atmospheric spectacle, where energy and chaos manifest in brief intervals, in a setting where sunlight is barely a whisper. Observing Neptune's dark storms is like peering into the natural laboratory of extreme meteorology. It reminds us that even in the coldest and most distant corners of the solar system, planets can harbor atmospheric dynamics as powerful as they are unpredictable. These storms, with their sudden appearance and disappearance, challenge us to keep exploring and questioning what other secrets lie behind Neptune's deep blue veil. What makes Pluto, that small, icy world on the fringes of the solar system, continue to captivate the imagination of scientists and the curious? Pluto was considered the 9th planet for over 70 years, until in 2006, the International Astronomical Union redefined what it means to be a planet. Since then, Pluto belongs to the category of dwarf planets. But why is this distinction so relevant, and what other worlds share this characteristic? Beyond Pluto, there is a region called the Kuiper Belt, a kind of ring of icy debris and rocky bodies that surrounds the outer solar system. This belt is filled with fascinating objects, some as large as Pluto, like Eris, Haumea, and Makemake. What makes them so special? Although they are much smaller than the main planets, these worlds share surprising characteristics: elliptical orbits, ice-covered surfaces, and atmospheres that can appear and disappear depending on their distance from the Sun. In a way, exploring the Kuiper Belt is like peering into a museum of the solar system's formation, where the primitive remnants of the time when it all began are preserved. Could life exist on these remote and cold worlds? The temperature on Pluto can drop below -230 degrees Celsius, and sunlight barely arrives as a faint glow. However, some scientists wonder if beneath its icy crust there could be a subsurface ocean, protected from the extreme cold, where microscopic life could find refuge. This hypothesis, although not yet confirmed, has changed the way we view the limits of habitability in the solar system. And why is it important to continue exploring these dwarf planets? Each one is a time capsule that holds secrets about the formation and evolution of the solar system. By studying their orbits, compositions, and atmospheres, astronomers can reconstruct the history of the early days of the Sun and its planets. Ultimately, Pluto and its neighbors in the Kuiper Belt remind us that, even in the farthest and most extreme corners, the solar system is full of mysteries waiting to be discovered. Pluto, that icy world that for a long time was considered the 9th planet of the solar system, holds secrets as fascinating as they are extreme. Can there be snow in such a distant place from the Sun? The answer is yes, but not snow like we know here on Earth. On Pluto, temperatures are so low that gases like methane, nitrogen, and carbon monoxide can freeze and precipitate onto the surface in the form of snow. Can you imagine a storm where instead of water flakes, methane crystals fall? On Pluto, this is an everyday reality. But why does methane turn into snow on Pluto and not elsewhere? It all has to do with temperature. On this dwarf planet, the average temperature hovers around 230 degrees below zero. Under those conditions, methane, which is a gas on Earth, freezes and forms a shiny, whitish layer on the surface. Thus, some of Pluto's mountains and plains are covered by a kind of methane frost, which reflects sunlight and gives it that bright and mysterious appearance. If we could walk there, our steps would crunch on such exotic snow that defies the imagination. What effects does this methane snow have on Pluto's landscape? Scientists have observed that regions where this snow accumulates tend to be brighter and colder, creating an impressive contrast with darker areas rich in tholins, complex organic compounds that stain the surface with reddish hues. This interaction between methane snow and tholins reveals the great variety of geological and atmospheric processes occurring even in the most remote corners of the solar system. It's as if Pluto were a natural laboratory testing the limits of what is possible. But this raises a fascinating question. How does methane get into Pluto's atmosphere to then precipitate as snow? Scientists believe that methane is released from the interior of the dwarf planet through cracks and cryovolcanoes, that is, ice volcanoes. When Pluto gets closer to the Sun in its elliptical orbit, some of this methane sublimates, changing from solid to gas and forming a thin atmosphere. However, as it moves away from solar heat, the methane refreezes and falls, covering the ground with another layer of snow. Thus, Pluto experiences a snow and thaw cycle completely different from that of Earth, but equally fascinating. In short, methane snow on Pluto is a clear example of the diversity and creativity of nature in extreme worlds. Where on Earth we associate snow with fun and winter cold, on Pluto it is synonymous with a hostile, exotic environment, still full of mysteries to discover. Who would have thought that billions of kilometers from the Sun, such a small world, could have such unique landscapes and such complex processes? What would happen if a planet had an atmosphere that appears and disappears as if by magic? Pluto, the icy world of the Kuiper Belt, defies expectations with an atmosphere so volatile and fragile that it could completely vanish depending on the time of year. When Pluto is closest to the Sun, its icy surface of nitrogen, methane, and carbon monoxide begins to sublimate, meaning it transitions directly from solid to gas, creating a faint atmosphere that temporarily envelops the dwarf planet. But why does this extreme phenomenon occur? The key lies in Pluto's eccentric orbit and tilted rotation. As it approaches its perihelion, the closest point to the Sun, the temperature rises, though it remains incredibly cold, enough to release gases from its icy surface. Thus, Pluto acquires an atmosphere primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere is so thin that the pressure at the surface is hundreds of thousands of times lower than that of Earth, yet it still has a notable effect. For example, scientists have observed that it can produce bluish mists, similar to those we see at dawn or dusk on Earth, though much more ethereal and exotic. However, this gaseous mantle is ephemeral. When Pluto moves away again toward aphelion, the farthest point in its orbit, temperatures plummet drastically. Then, the atmosphere freezes and falls as frost onto the surface, almost completely disappearing. Can you imagine a place where the sky simply ceases to exist for part of the year? This cycle of appearance and disappearance is one of the most unique phenomena in the solar system and reminds us how dynamic even the seemingly most inert and distant places can be. Pluto's atmosphere is not only temporary, but also vulnerable. Just small changes in distance from the Sun can radically transform it. Furthermore, Scientists wonder if this process could be repeated in other objects in the Kuiper belt, or if it is exclusive to Pluto. Could there be even more distant worlds with atmospheres that breathe and extinguish in slow, mysterious cycles? The study of Pluto's atmosphere not only helps us understand this dwarf planet, but also invites us to imagine other extreme scenarios in the far reaches of the solar system. What is the coldest planet in the solar system, and the hottest? Temperatures on the planets vary so much that if we tried to make a chart, it would look more like a catalogue of cosmic hells and freezers. For example, Venus is the absolute champion of heat. Its surface reaches temperatures above 470 degrees Celsius, enough to melt lead. But how can a planet that is not the closest to the Sun be the hottest? The out-of-control greenhouse effect on Venus traps heat like an impossible-to-remove thermal blanket. On the other end, Uranus takes the title of the coldest planet, with temperatures dropping below -224 degrees Celsius. Neptune is close, but Uranus surpasses it due to its lack of a significant internal heat source. It is so cold that if we had liquid water there, it would instantly freeze into a solid block. And if you think Pluto, although no longer considered a main planet, might be colder, you'll be surprised to know that at times Uranus ranks higher in the freezing stakes. Earth finds itself in an almost miraculous balance. The global average temperature is about 15 degrees Celsius, although of course lethal temperatures can be found at the poles and in extreme deserts. But if we compare our planet with its neighbours, the difference is staggering. Mercury, for example, experiences the greatest thermal swings. During the day, its surface can exceed 430 degrees Celsius, and at night it can drop below -170 degrees. It's like going from the oven to the freezer in a matter of hours. Jupiter and Saturn, being gas giants, do not have a solid surface where temperature can be measured like on rocky planets. However, if we delve into their atmospheres, we find extreme conditions. The upper layers of Jupiter can be at -145 degrees Celsius, while in the core, temperatures could reach tens of thousands of degrees. In other words, we could compare the surface of Jupiter to the most inhospitable Antarctica, and its core to the interior of a star. If you're wondering what these extreme differences tell us, the answer is simple. Life, as we know it, is only possible within a very, very small range of temperatures. While some terrestrial microorganisms can survive in extreme conditions, no living being we know could withstand the thermal horrors of Venus or the icy abysses of Uranus. The variety of temperatures on the planets is a reminder of how special our own world is, a true oasis amid extremes. What do you think is the difference between standing on Earth and doing so on Jupiter? The answer goes far beyond simple size. Pressure and gravity are two of the most extreme and determining factors on each planet in the solar system, capable of crushing, squeezing, or making you feel almost weightless. Let's start with gravity. On Earth, this force keeps us firmly grounded, gives us weight, and structures our daily lives. But what would happen if you tried to walk on the surface of Jupiter? Gravity on Jupiter is about 2.5 times stronger than on Earth. That means if you weigh 70 kilos here, you would feel like you weigh almost 180 there. Every step would be a feat, and your bones and muscles would be under tremendous pressure. But, ironically, you could never step on its solid surface because it simply doesn't exist. You would just sink into a dense and hostile atmosphere. Now, let's think about atmospheric pressure. On Earth, we are used to a pressure that, although we don't notice, keeps the air in our lungs and water in a liquid state. But on Venus, the pressure is so crushing that it's equivalent to being almost a kilometer deep underwater on Earth. Can you imagine? If a human were to reach the surface of Venus without protection, they would be crushed in an instant. This makes Venus one of the most hostile worlds for any type of exploration, even surpassing Jupiter in this aspect, as the pressure on the Jovian's surface increases progressively as we descend into its atmosphere, becoming lethal long before reaching any core. What about the lighter planets, like Mars or Saturn? Mars has a gravity that is barely a third of Earth's. There, you could jump 3 times higher and carry heavy objects as if they were feathers. But the atmospheric pressure on Mars is so low that water cannot remain liquid on its surface. It would either evaporate or freeze instantly. Saturn, on the other hand, has gravity only slightly greater than that of Earth, but lacks a solid surface. If you tried to stand on Saturn, you would simply sink into a sea of hydrogen and helium, while the pressure would rapidly increase to become intolerable for any known structure. And if we look towards the extremes of the solar system, Uranus and Neptune present their own challenges. Although their surface gravities are similar to that of Earth, the pressure within their atmospheres grows spectacularly. In the case of Neptune, for example, the pressure in the depths is enough to compress gas into exotic forms of hot ice, challenging our understanding of matter. Even on Pluto, gravity is so weak that an adult could easily jump several meters, but its atmospheric pressure is so low that it barely exists. In summary, pressure and gravity are the invisible forces that shape the identity of each planet and determine whether life, or even machines, could withstand its surface. While gravity defines how anchored we are to the ground, pressure determines whether we could breathe, move, or simply exist. Thus, each world presents a unique challenge, from being crushed by dense atmospheres to floating almost weightless under distant skies. Which of these extremes do you think would be the most difficult for life as we know it? What would happen if we tried to breathe on another planet in the solar system? The answer is almost always the same. It would be deadly within seconds. The atmospheres of our planetary neighbors are genuine toxic cocktails, very different from the mix of oxygen and nitrogen we enjoy on Earth. For example, Venus is shrouded in a dense atmosphere, mostly composed of carbon dioxide and sulfuric acid clouds. Breathing there would be like inhaling poisonous smoke mixed with droplets of acid. Even a spacesuit could barely protect us for a few minutes. And what about the pressure? On Venus, the weight of the air is so crushing that it's equivalent to being 900 meters underwater on Earth. On Mars, the story is different, but equally lethal. Its atmosphere is also rich in carbon dioxide, but so thin that it's barely felt. If you tried to inhale on Mars, the air simply wouldn't fill your lungs, and as if you were at the top of the highest mountain multiplied by 100, you would suffocate immediately. Additionally, the lack of a protective layer allows solar radiation to penetrate unobstructed, akin to receiving an extreme sunburn in just minutes. Jupiter and Saturn present an even more hostile landscape. Their atmospheres are made up of hydrogen, helium, and, in smaller proportions, ammonia and methane. Not only are they toxic to any form of terrestrial life, but they also lack a solid surface to land on. If for some reason we could float in their atmosphere, we would be surrounded by poisonous gases and subjected to pressures and temperatures that would destroy any spacecraft in seconds. It's like trying to survive inside a gas storm so dense and dangerous that no human technology could withstand it. But is there any planet less hostile to life? When we compare all these environments, Mars, despite its unbreathable atmosphere, is the least aggressive for technology and humans protected by spacesuits. Its low pressure and absence of chemical storms make it less deadly than Venus or the gas giants. However, none of the planets in the solar system, except for Earth, have an atmosphere capable of sustaining life as we know it. The combination of gases, adequate pressure, and protection against radiation seems to be a unique balance on our planet. Thus, the search for habitability in the solar system is, for now, a matter of finding the least hostile, not the hospitable. Can life exist in the most extreme environments of the solar system? This is one of the most fascinating questions that modern science seeks to answer. When we observe planets with temperatures that melt lead, atmospheres so dense they would crush any spacecraft, or radiation storms capable of destroying all forms of terrestrial life in seconds, it seems impossible to imagine that anything could survive there. However, do we really know the limits of life? Let's consider for a moment what is necessary for life to exist. On Earth, life has proven to be incredibly adaptable, finding ways to thrive in the most inhospitable places, from volcanic ocean floors to the driest deserts. But could that adaptability extend to other planets? Venus, for example, has surface temperatures exceeding 400 degrees Celsius and an atmosphere of sulfuric acid. Mars, in contrast, is a frozen desert bombarded by radiation. Could it be possible that some form of life, perhaps completely different from what we know, could arise and survive in such extreme conditions? The key might lie in the definition of life. Must it necessarily breathe oxygen, or can it depend on other elements like methane or ammonia? In places like Titan, a moon of Saturn, rivers and lakes are not made of water, but of liquid methane. Could there be organisms that use that methane as the basis of their metabolism? Furthermore, life wouldn't necessarily have to develop on the surface. In the depths of the subsurface oceans of Europa or Enceladus, shielded from radiation and extreme cold, there could be niches where the right chemistry allows for the existence of microbes. Therefore, although the conditions on most planets seem hostile to life as we know it, we cannot dismiss the possibility that life adapts and thrives in ways we have yet to imagine. The question is not just whether there is life on those extreme worlds, but whether we are looking in the right place and with an open enough mind to recognize it if we find it. Each extreme planet challenges us to rethink what it means to be alive and how far the resilience of life in the universe can go. Is it possible that life exists in the most extreme environments of the universe? To answer that question, we must first look at Earth. Here, there are forms of life that challenge everything we thought was possible. They are extremophiles, organisms that thrive in conditions so hostile that, for any other creature, they would be lethal. Can a living being survive temperatures close to 100 degrees below zero, or withstand acids as corrosive as those that destroy metal? For extremophiles, these conditions are not only tolerable, but they're home. For example, thermophilic bacteria live in hot springs where the water constantly boils. There are microorganisms that inhabit the hydrothermal vents on the ocean floor, enduring pressures that would crush a submarine and temperatures exceeding 100 degrees Celsius. Other extremophiles, such as acidophiles, resist environments with acidity levels comparable to battery acid. Halophiles, on the other hand, thrive in hypersaline lakes, where the salt concentration far exceeds that of the sea. There are even radiation-resistant organisms, like the famous Deinococcus radiodurans, capable of surviving radiation doses that would kill any other living being in seconds. What do these tiny beings teach us about the search for life beyond Earth? Extremophiles demonstrate that life does not need ideal conditions like those we enjoy on the Earth's surface. They can thrive in corners where light is non-existent, oxygen is scarce, and energy comes from unusual sources, such as chemical reactions between rocks and water. This expands the range of places we might consider habitable on other planets and moons. If life can withstand the acids of Venus's clouds, the extreme cold of Mars, or the radiation of Jupiter, why not imagine it in even stranger worlds? Extremophiles act as windows into Earth's primitive past and as models for understanding the possibilities of life in the universe. They force us to rethink our definition of habitable zone and to look with new eyes at environments we once considered absolute deserts. Could life exist beneath the ice of Europa, Jupiter's moon, or in the methane lakes of Titan? The existence of extremophiles invites us not to dismiss any possibility and to keep exploring, because life, like water, always finds a way, even in the most unexpected corners of the cosmos. How does humanity face the challenge of exploring worlds so hostile that human survival would be impossible even for a few seconds? The answer lies in robotic exploration, a true feat of modern engineering. The robots and probes sent to the extreme planets of the solar system are like brave explorers, designed to withstand conditions that would destroy any crewed spacecraft. But how difficult is it really to send a machine to places where pressure can crush steel, radiation can disintegrate circuits, and temperatures can freeze or melt any known material? One of the biggest challenges is communication. For example, When a probe explores Mars, the signal takes several minutes to reach Earth. But if the mission is to Neptune or Pluto, the wait can be several hours. It's like trying to control a drone remotely, but with such a large delay that any mistake could be fatal, and there would be no way to correct it in time. That's why these machines must be incredibly autonomous, capable of making quick decisions without direct human intervention. How do you program a robot to react to the unknown? Engineers must anticipate almost every possible problem, from giant dust storms to electrical failures caused by extreme cold. The physical environment of each planet presents unique obstacles. On Venus, probes face temperatures capable of melting lead and an atmospheric pressure that could crush a submarine. The Soviet Venera missions only survived a few minutes on the surface before becoming inoperable. On Jupiter, radiation is so intense that it can destroy electronic components in a matter of hours, forcing the shielding of systems with special materials. And on Mars, fine dust can infiltrate all mechanisms, blocking solar panels or jamming wheels, as happened to the Spirit rover. It's a bit like sending a robot to survive at the bottom of the ocean, but without knowing exactly what creatures or currents it will encounter. Energy is another monumental challenge. Far from the Sun, as in the regions of Uranus, Neptune, or Pluto, sunlight is so weak that solar panels become useless. That's why many probes rely on nuclear generators, capable of producing electricity for decades. But even with enough power, the cold can freeze liquids and cause gears to contract until they break. How do you design a mechanism that works in both sub-zero temperatures and in hellish heat environments? This is where the creativity of engineers is put to the test, developing materials and systems that push the limits of current technology. Despite these difficulties, robotic exploration has allowed us to see landscapes we could never have imagined and answer fundamental questions about the universe. Each successful mission is the result of years of preparation, thousands of tests, and above all, the human capacity to dream of reaching beyond the possible. What new secrets will the next robots sent to the extreme planets reveal? Only the future will tell. But each challenge overcome brings us a little closer to understanding the mysteries of the solar system. What will be the next big leap in the exploration of the most extreme planets in our solar system? Just a few decades ago, the idea of sending probes to distant worlds was a science fiction dream. Today, we find ourselves on the brink of a new era, where technology not only allows us to observe from afar, but also to imagine missions that can land, drill, and directly analyze the most hostile environments. Will we ever be able to send robots that can withstand the crushing pressure of Venus or the lethal cold of Neptune? Advancements in artificial intelligence and robotics are transforming the way we conceive planetary exploration. Future probes will be much more autonomous, capable of making real-time decisions and adapting to unexpected conditions, as if they were explorers with their own instincts. What does this mean? That we could see robots navigating through the dust storms of Mars without getting lost, or probes surviving the supersonic winds of Neptune. Just like the pioneers who crossed oceans without maps, these machines will have to face the unknown with ingenuity and resilience. Are we close to sending humans to other planets? While human exploration of Mars is one of the most ambitious goals, the challenges remain enormous. Radiation, lack of gravity, and the need for long-term life support pose colossal obstacles. However, technologies such as 3D printing to build habitats on site, closed-loop water, and air recycling systems, and even the use of local resources to produce fuel are bringing that dream closer to reality. A new generation of spacesuits and vehicles designed to withstand extreme conditions is being developed, inspired by the most resilient materials on Earth. International collaborations and the involvement of private companies are accelerating the pace of exploration. New missions, such as orbiters and rovers destined for the icy moons of Jupiter and Saturn, promise to reveal hidden secrets beneath layers of ice. What could we find in those underground oceans? The search for life and the understanding of the limits of habitability are driving an unprecedented technological race. The future of planetary exploration will be a combination of human ingenuity, advanced automation, and an insatiable curiosity to discover what lies beyond. Are we ready to take the next step and become interplanetary explorers? Everything indicates that the next frontier is much closer than we imagine. What do the most extreme planets in the solar system teach us about our place in the universe? By comparing the conditions of each world, from the scorching skies of Venus to the frigid nights of Neptune and Pluto, it becomes clear that our solar system is a true laboratory of extremes. If Earth were a perfect recipe for life, the other planets would represent the ingredients that, when mixed in different proportions, yield results as surprising as they are inhospitable. How can life adapt, if it can, to temperatures that melt lead or pressures capable of crushing any human-made artifact? The diversity is astonishing. There are atmospheres that are genuine oceans of acid, pressures that exceed our planets by dozens, winds that travel faster than a supersonic jet, and surfaces covered in exotic ice or red dust. These extremes not only challenge our technological limits, but also expand our imagination. Could we one day find life in such hostile places, or is Earth the exception in a universe of contrasts? Each planet seems to pose a question to space. What does it really take for life to emerge and thrive? Reflecting on these worlds is, at its core, reflecting on ourselves. Why did life flourish here and not there? What makes Earth unique in the face of the violent dance of storms, lethal cold, and corrosive rains on other planets? As if the solar system were a kind of puzzle, each piece gives us clues about the limits of the possible. Scientists wonder if in some corner, beneath layers of ice or in toxic atmospheres, some form of resilient life could be hiding, different from anything we know. Exploring these extreme worlds reminds us that existence is, in itself, an extraordinary phenomenon. If life managed to arise on Earth, why not in some other corner of the cosmos, under conditions we are just beginning to understand? Each discovery brings us closer to answering the big question: are we really alone, or is the universe full of surprises waiting to be found? In the journey through the most extreme planets, we learn that seeking answers beyond Earth is ultimately a way to understand the wonder of being here.